Let us discuss about the nucleophilic addition reactions of aldehydes and ketones. Nucleophilic addition reactions of aldehydes and ketones. So they both undergo nucleophilic addition reactions, but ketones are less reactive than aldehydes due to more crowding and more electron density at the carbonyl carbon. Now this is general reaction we represent. This is carbonyl group and this is our reagent containing electrophile and nucleophile. Electrophile adds to carbonyl oxygen and the nucleophile adds to carbonyl carbon. As a result, the hybridization of the carbon changes to sp3. So this carbon is now sp3 and this carbon was sp2. And the shape is also changing from trigonal planar to tetrahedral. Now the first reaction is a reaction with a hydrogen cyanide or hydrocyanic acid. This is a weak acid, so it does not give H plus ion very easily. So to remove H plus ion, we use the basic conditions. So we use hydrogen cyanide in the presence of a base. And in this case, the Cn minus is your nucleophile and H is the positive group electrophile. So aldehyde ketones, the carbonyl group on reaction with the hydrogen cyanide in basic medium, OH minus gives a cyanohydrin. So H adds to oxygen and Cn adds to the carbonyl carbon. This is called a cyanohydrin. And via this we can add one carbon to the carbonyl carbon. We can increase the carbon atom. And once the Cn is obtained, this can be hydrolyzed to give in acidic medium gives a carboxylic acid. Now this is called alpha hydroxy carboxylic acid. Alpha hydroxy acids. So we'll discuss one question. Now the question is convert. This is a very important question. Convert ethanol into 2-hydroxy propanoic acid. 2-hydroxy propanoic acid. And the question can be framed in different ways. This is one form of the question, ethanol into 2-hydroxy propanoic acid. Now this is ethanol and we react this compound first with hydrogen cyanide in alkaline medium. It gives a cyanohydrin and this on hydrolysis gives 2-hydroxy propanoic acid. And this 2-hydroxy propanoic acid is also known as a lactic acid. So question can be framed in different ways. Ethanol into 2-hydroxy propanoic acid. What happens when ethanol reacts with the hydrogen cyanide? What happens when this cyanohydrin is being hydrolyzed? So different forms of questions can be framed. This is ethanol. Now the second reaction is the reaction with the alcohols. And only primary alcohols give this reaction. Only 1-degree alcohols, because they are the most acidic, they can release H plus ion very easily. Now this is carbonyl group. On reaction with alcohol, this is a primary alcohol. It's a monohydric alcohol, contains only one OH group in acidic medium HCl. It gives this product. The addition takes place. H adds to oxygen and this negative group adds to the carbonyl carbon. This is called hemiacetal. And this on further reaction with the same alcohol, same monohydric alcohol in acidic medium, undergo dehydration, loss of water to give an acetal. This is called acetal. So if we are starting with aldehydes, aldehydes first gives a hemiacetal and then gives acetal. And ketones first gives a hemiketal and then gives a ketal. We will discuss two questions on this. Now this is our ethanol. When it reacts with the ethyl alcohol in excess. Now we are using alcohol in excess, so it gives acetal as a final product in acidic medium. So the product obtained is this. This is called acetal. Now instead of using two molecules of a monohydric alcohol, we can also use one molecule of a dihydric primary alcohol. For example, this is glycol. It's a dihydric alcohol. Now dihydric alcohol directly results in the formation of a cyclic compounds, and it's a 5-membered ring, so is stable and exist. Now this is called ethylene because its name is ethylene glycol. So this product is called ethylene acetal if we are using aldehyde as the starting compound, ethylene ketal if we are using ketone as a starting compound. Now this is a question. Write the structure of the ethylene ketal of cyclobutanone. Now it's a difficult question. It's not easy to write the structure directly of this reaction. So you write the reaction first. So we are reacting the cyclobutanone with ethylene glycol. Now this is the ethylene glycol. So you write the structure. Now this is the product obtained. And then you write this as the final answer. So this is structure of the ethylene ketal of the cyclobutanone. Now next is the reaction of aldehyde and ketones with ammonia derivatives. Now when we say ammonia derivatives, it means one H of the ammonia has been replaced by some group, ammonia derivatives. So this is ammonia, NH3, but one H has been replaced by some group called Hg. This is ammonia derivative, and this ammonia derivative can act as a nucleophile and undergo nucleophilic addition elimination reaction with carbonyl group. In acidic medium, it forms this. So the loss of water takes place here. This is nucleophilic addition elimination. Nucleophilic addition elimination reaction. These are also called condensation reactions. Now this G can be different groups. Now if G is equal to NH2, then the reagent is called a hydrazine. This is called hydrazine, and the product obtained is then called hydrazone. So just write this hydrazone as a suffix to the parent compound when you're writing the nomenclature. Now second is NH and phenyl. Now this is called phenylhydrazine. One H of the hydrazine has been replaced by phenyl group. This is called phenylhydrazine. And the product is called a phenylhydrazone. So again, if you have to write the name, you just write phenylhydrazone as a suffix to the parent compound. Ethanol phenylhydrazone, propanone phenylhydrazone, and so on. Now the third is if G is equal to NH, and this is phenyl with the two nitro groups at 2 and 4 position, then our reagent is called this is called 2,4 dinitro phenylhydrazine. Its short form is 2,4-DNP, with which the product obtained is a yellow or orange PPT. And this formation of a yellow or orange precipitate is used as a test for the carbonyl group. This is a yellow or orange precipitate. Now similarly, G can be this also, OH. Then the reagent is called hydroxylamine. Hydroxyl means OH and amine means NH2. This is hydroxylamine, and the product obtained is called oxime. So you just write oxime as a suffix to the parent compound. And the last one is, if G is equal to this, then the reagent is called a semi-carboside. This reagent is called semi-carboside, and in this case only this NH2 participates in the condensation with aldehyde ketones, participates into condensation with aldehyde and ketone. So you have to be very careful. This does not participate. This NH2 does not show a nucleophilic properties because the lone pair of electrons on nitrogen is delocalized with the CO group. So it does not show the nucleophilic property, so this has to be used, and the product obtained is called a semi-carbazone. This is called semi-carbazone. And the reaction with ammonia derivatives uses a test for the carbonyl group. Now this is one question. Write the structure of the semi-carbazone of cyclopentanone. So again you write the reaction first. This is cyclopentanone, and this is semi-carboside. So you have to be very careful which NH2 group you have to use. This NH2 group you have to use, and the product obtained is this, and you write this final product as your answer. So this is our final answer. This is structure of the semi-carbazone of cyclopentanone. And the last reaction is a reaction of aldehyde and ketones with a sodium hydrogen sulfite. This is called sodium hydrogen sulfite. And the reaction with sodium hydrogen sulfite also used as a test for the carbonyl group. But you cannot distinguish between aldehyde and ketones using NaHSO3. Now this is carbonyl group. On reaction with NaHSO3, first it gives this product, and this is unstable and undergo proton transfer and give this crystalline product. And formation of this crystalline product is a test for the carbonyl group. This is crystalline product. But you should not write this as a test for the carbonyl group. You prefer 2,4-DNP. But if we are writing in the question that the compound is giving a crystalline product with NaHSO3, you can draw your conclusion that my product is either aldehyde or ketone. Now this is one question. And the question is, write the final product, NaHSO3 in acidic medium. So in this case, the final product is this. This is our final product. This is a crystalline product. So this is all about the nucleophilic addition reactions of aldehydes and ketones.